So that means I need to find the change in distance or change in position between 0 and 1. So I'm going to start with the later distance and subtract the earlier one. And then I've got to do from 1 to 3. So I'll start with the later one and subtract the earlier one. And then I've got to do the 5. I'm supposed to stop at 5, so I would be doing the change in distance from 5 to 3. Because remember, this is where velocity was positive and this is where velocity was negative, and this is where velocity was positive again. So I want to treat them separately. As a matter of fact, it would be safe if I just said, okay, take absolute value of all of it, but the one that I'm expecting to be negative is actually this middle piece. So I really need to make sure that I absolute value that middle piece, because I'm pretty sure it's going to turn out negative since the velocity was negative. Okay, so now I'm just going to substitute in 1 into the position function, and then 0, and then 3, and then 1 again, and then 5, and then 3. So go all the way back to your position function and plug that in and see what you get. Okay, so those should be all the numbers. I will show you in class tomorrow how to put these into your calculator to make it a little more efficient, but remember, you potentially have to do that without a calculator. But I'll show you how to use your calculator also. So now if I simplify all of those sections, I'm going to have 4 plus, remember I'm absolute valuing this middle piece. Look, it's coming out negative. I suspected that. And when I absolute value it, I get a positive, and then 20. So my total distance for the first 5 seconds was 28 meters. Not too bad, calculates. Okay, number 4, that's the notation for second derivative. Looks a little scary. Notice how I put the little exponent up here. It goes in between for the y, but with respect to x, it stays on the outside. Technically, I'm doing that. So I just want to take second derivative. Oh my goodness, this is a quotient rule. Yikes, yikes, yikes. I better erase the board. Okay, so my first derivative, I'm doing low. There it is. And then d high would be 2x plus 2 minus high, and d low would be 1 all over low squared. So now I want you to pause the video and see if you can do all the algebra to get that correct. Simplify it out. Hope that's what you got. Okay, so now we got to take the derivative of that. I'm going to erase my board before I start. Okay, so let's work on this thing. So I got to do low. Derivative of the high would be 2x minus high d low, that would be 2x all over low squared. Again, pause the video, see if you can get it all the way simplified down. Did you get that, calculus wizards? Check your work. Okay, might have to talk really fast so I can finish this video before time runs out. I got 1 minute and 20 seconds. So if I want to find acceleration, I have to take the derivative of the velocity. It's a quotient, so I'll have to use quotient rule. Pause, see if you can do it by yourself. Hopefully we match. You got the same thing I did. And then I'm supposed to find it at 5 seconds. Remember, this is a of t. So I'm going to plug in 5. And I'll have, oops, I didn't mean to do that. So check all of your math calculations, and I get 2.4 feet per second squared. Acceleration is feet per second squared. Okay, that's it for today. I will see you in class tomorrow. Had a great day. Great celebration with all of my calculates. Bye.